A quick one, just before we move on to the division of sets, I just realized there could be more complex cases for the multiplication than we've looked at. So let's quickly touch on that and then we can move on. So in the case where we have let's assume 5 roots 5, right? Plus 3 roots 2. Let's assume that this is multiplying another whole bracket of, let's say, 2 roots 7 plus root 8. Let's keep it this way. All right, so here there's a bit of a trick here, right? I just tried to bring this so we can just be able to identify whether we can move on straight ahead. So we can see here, right? I can see root 8, right? Root 8, is that the final form of that set? Not really, right? We can get a perfect square from this, right? And the perfect square is what? 4. And 4 times 2 is giving us the 8. So we have to try and simplify this before we move on. So that's 5 root of 5 plus 3 root of 2. All right. And then we have 2 root of 7 plus this is going to be what? We know that's 4 times 2 roots. 4 times 2 all under the root. And root of 4 is what? 2. Root of 2 still remains 2, right? So we need to have this before we go on to expand our bracket, right? So let's expand. So we know that when we have cases like this, each term in the first bracket multiplies the whole of the second bracket, and then each term in the first bracket multiply the whole of the second bracket. So let's take the first term. We have 5 root of 5 multiplying 2 root of 7 plus 2 root of 2, and then plus 3 root of 2 multiplying 2 root of 7 plus 2 root of 2. All right. Okay, so now let's go on and expand. So we have 5 root of 5 multiplying 2 root of 7. We know our coefficients are going to multiply, right? So we have 5 times 2, that's 10. Now we have root of 5 times 7, that's 35. Then plus 5 root of 5 times 2 root of 2. We know 5 is going to multiply 5, we have 10. And then root of 5 times 2, that's 10 also. And then plus the second bracket, we have 3 root of 2 times 2 root of 7. So these two going to multiply this 3, that's 6. And then root of 2 times 7, that's 14. And then plus 2 root of 3 times 2 root of 2. These two going to multiply this 2, that's 6. And then root of 2 times 2, that's 4. And I would like us to not to go that long way. We know root of 2 root of 2. We know root 2 times root 2 is just going to be what? 2, as we saw from this side, right? Okay, so now let's simplify this. Is 35 a perfect square? No. Can we get a perfect square from this? No. How about 10? No. 14? No. Okay, so it means that we can't simplify the sets any further, and so we just have to see if we have like terms. If we have like terms, we know we are going to add or subtract them. If not, then we can't do anything about that. Over here we don't have like terms. It's root of 35, root of 10, root of 14. We don't have like terms, but then we can just simplify this 6 times 2 and then we move on. So we have this 6 root 14 plus 12. So basically that's the end of this solution, right? And let's quickly look at another form that this could have, right? So we have 2 root of 2 minus root 6, and then we have 2 root of 2 plus root of 6. So basically what we're going to do, as we saw in the previous example, is to expand the brackets. And we know if you have two brackets multiplying each other, each term in the first bracket multiplies the second bracket. So let's see. So we have 2 root of 2 multiplying 2 root of 2 plus root of 6. Right now I have this is root of 6, but it needs to come with its sign, which is minus root of 6 multiplying 2 root of 2 plus root of 6. Right, okay, so now let's expand the brackets. So we have 2 root of 2 times 2 root of 2. So what does this give us? We know 2 times 2, that's 4, right? And then root of 2 times root of 2, we know this should give us what? 2, right? Now we have 2 root of 2 plus root of 6, right? So we have 2 times 1, that's 2, right? This is plus, right? So we have 2, right? Root of this times this is what? 12. Is that okay? Then minus, we come to the second bracket, we see this, that's the coefficient here is 1. 1 times 2 is 2. Root of what? 6 times 2 is 12. And then minus root of 6 times root of 6. That gives us what? Root of what? 6 times 6, that's 36. But I can, choose not to write this 36 and then write what? 6. Right? Because we saw from the first rule that, root of 6 times root of 6 should give us what? 6. All right, now let's simplify this quickly. We have this is 8 plus we have this is 2. Root of 12, is that the final form of the set? Not really. We can simplify in it. So we know we can get a perfect square from 12, and that perfect square is what? 4. Right? So we have 4 times 2 giving us what? 4 times 3 giving us what? 12. So that becomes what? Root of 4, which is 2. So that 2 comes out, and it's it has to multiply these 2. Then root of, we have 3, right? Because we are not able to find the square root of 3 as a whole number, to give us a whole number. And then we come here, we have what? Also similar situation, right? This is, it's actually the same thing, 2 root 12, and this is also 2 root 12. So we know it's going to give us what? 2 times 2 root 3, and then here is minus 6. So we have 8 plus, this is what? 4 root 3, and then this is minus 4 root 3, and then this is minus 6. We have 4 root 3 minus 4 root 3, and we know it gives us 0, right? And this becomes 8 minus 6. That gives us what? 2. So that's the answer for this. And I just want to draw your mind back to something, right? So when you have this, something like this, this follows the form of the difference of two squares, right? So we know from difference of two squares that if we have a squared minus b squared, that gives us what? A minus b, right? And then a plus b. So immediately I see that whatever is here is the same thing as what is in the bracket, but only the sign changes. Then I know that what I'm dealing with difference of two squares. So what I have here, if I have to simplify this, I can just follow the difference of two squares or principle, which says that these two things in the bracket, I should just take the first one, square it, take the second one, square it, and then what? Subtract. Easy, in it. So let's see. So it means that this whole thing here is going to give me what? 2 root of 2. I'm going to square it, then minus, because this is minus, and then what? Root of 6. I'm going to square it, and so this gives me root of, so now a little bit of attention here. So I'm squaring everything here, so it means I'm going to square what? These two, and since this root 2 is multiplying, I'm also going to do times the square of this. So the square of 2 is 4 times the square of root 2. Basically you know that what? The square of root 2 is the square is going to take away the square root, right? So I'm going to get 2 minus root of 6 squared is also going to take away the square root, so I'm going to get 6, and this is 8 minus 6 giving me 2, right? So sometimes in such situations it's good you are able to easily spot that I have such a situation, and it helps you solve your problem easily. All right, so that's the end of this episode. We're going to look at how to deal with divisions, and then also when you have surds as your denominator when you are adding and subtracting.